In this video, we're going to be looking at how we can apply H3 to aggregate and map all of our data. So firstly, a bit of a rundown on the H3 indexing and what that looks like in code. Fortunately for us, there's the Polar's H3 extension. This allows us to really quickly add a H3 index to any latitude and longitude equipped dataset. You can see here we use this lat_long to cell function, and we specify which columns contain that information. We specify the resolution that we want to index at, and we're specifying the return type. This is quite important. Most of the libraries that we interface with prefer the string representation of the index rather than the integer representation. So if you're finding that there's some errors there, that could be a source for you. For the mapping section, we're using Pydeck. Unfortunately for us, there's a H3 Hexagon Layer plugin as well. For this layer to compute, all we need to do is specify the data frame. Notice that we're actually giving it a pandas data frame, and unfortunately it doesn't work with polars. So this is a small caveat. It's nice and fast still, and all of our aggregations are handled by the faster polars library. We also have to specify which column contains the H3 index, so that the layer can generate and knows which index to draw for which piece of data. Finally, we pass the layers on to the Pydeck deck. A Pydeck deck object is more or less a map, and similar to maps, you would set up your map and then tell the notebook to show it and display it for us to see. Here we have an example of what a H3 indexed piece of data looks like. So we can see that we've aggregated by the H3 index itself, and we've got the number of records as well as the dataset name. When we look at the resulting table, we can see that the records associated to this particular H3 index is only 1, and it comes from this Arctic tern tracking dataset. This is the data we feed into the mapping tools. So here we're finally importing Pydeck, ready for our visualization. You can see that we've got our utility function, generate Pydeck hexagon layers, being used here. Because we do this so often, we actually pulled it into a utility function. You can see more details about that in the video that corresponds to that information. We do our aggregation as shown above, and we tell our utility function that we want to aggregate on the number of records. This is going to be the heat indicator on our map. We also tell the number of quantiles we want to split the data into. Those are our buckets, and the color palette. Finally, we run the deck as shown above, and we submit our layers to the map, as well as the map style. Our tooltip is the information that appears when we hover over an item, and this also comes from the utility. And we set our global view state because we know that this dataset is global. And here is our map. So you can see there's a global spread of information about seabirds from this aggregated seabird dataset, and that in many of these locations there's a higher amount of records, and in many there's not many records. These tracking datasets in particular are a little bit sparse when they're tracking a particular tern. For example, these are all from the tern dataset. In this section of the video, we're going to be looking at the Australian marine regions. Now we've added these marine regions because the H3 index is not particularly human friendly to look at, and we saw that in the table earlier. These marine regions give us a bit more of a human friendly way to query because they're encapsulated as string text. The marine regions that we've added are the Commonwealth Marine Regions as well as the World Heritage Areas, although from the World Heritage Areas we've just grabbed the Great Barrier Reef. Most of the others are on land. We've also added the marine parks, the IMCRA provincial and IMCRA mesoscale regions. You can explore more information about these at these links that we provided in the table as well. For a bit of a taster, we've preloaded here in the notebook the Commonwealth Marine Regions. So if something is tagged in one of these marine regions, we'll see it in the string text, and it corresponds to this region on the planet. The marine region tags themselves are not completely self-explanatory, but they tend to look like this. They have a type and then a region. Some of them are a bit more complicated. So we've got this marine park, and then it has a optional super region, so it's a national park zone, and the actual region itself is Freycinet. Similar for some of these IMCRA ones as well, although there's 2 super regions. The most important thing to consider is what is the string text we're actually looking for. We don't need to take the entire tag, for example, when we do a filter. If we just wanted the cold temperate waters, we could say, give me where there's a string containing cold temperate waters. For an example of the Australian marine region tags, we can look at all of the unique tags and how commonly they appear in our dataset. So here we are, we've got all of our tags and how frequently they appear. We can see this southeast region appears the most, and at the bottom, the mermaid reef appears very infrequently, only once. The southeast region actually corresponds to this region on the Commonwealth Marine Regions. Another option for filtering with the Australian Marine Regions is just to take where a lat long has been tagged at all. We can see that's quite easy to do here, where we simply filter by the Australian Marine Regions tags not being null. In this section of the code, we've got a very similar piece that we had at the beginning in the H3 examples, where we can see we are first grouping by the H3 cell, but actually a little bit differently, we have a different resolution that we want to look at. So we're increasing the resolution, smaller hexagons. There's a bit of string manipulation here to allow us to have a better tag overlay when we hover over the icons. Let's see what the map looks like. So this is the same data set, but we've only got the data points showing where they actually fall in an Australian Marine Region. You can see here that the tags are also provided. So this one is in the Southeast Commonwealth Marine Region, as well as some other information for the IMCRA provincial and mesoscale regions. If we want to filter to a particular Australian Marine Region, we simply do a string contains filter. That looks like this piece of code at the top here, where we specify, for example, the Commonwealth Marine Southeast Region. This code above is similar to all of our other mapping, but you can see that the resultant hexagons that we're plotting are restricted to that southeast region.